In August 2004, the precise moment when a landslide reached catastrophic failure was caught on camera by a team from the Japanese Ministry of Land, Infrastructure and Transport. In this instance, there was sufficient warning and nobody was injured. But on average, landslides kill over 8,000 people every year, mostly in the developing world. Researchers from Durham University's International Landslides Centre visited the Japanese landslide site in order to map and measure its movement and analyse soil samples in the laboratory. At a time when we seem increasingly powerless before the ravages of nature, the International Landslide Centre has made great strides in understanding and predicting landslides.
Well, the primary aim of the Landslide Centre is to help developing countries in particular to deal with landslide problems that they face. And there are three main activities that we undertake. First, and perhaps the most important, is that we undertake fundamental research into landslide problems in those countries. So we go out and we measure landslides, we use laboratory techniques to investigate them, we try to develop schemes for assessing where landslides might happen in the future. The second activity that we do is a disaster response. So we have a team on 24-hour standby to fly out to developing countries to help them to deal with landslide problems that have occurred at very short notice. The third activity we undertake is trying to build up capability within developing countries to deal with landslide problems.
In order to understand the nature of landslides, they have developed a number of research techniques of their own. The analysis of soil samples taken from within landslides have taught them a great deal about how a landslide is set off. They designed and built their own back-pressured shear box to simulate conditions within a landslide. Rainfall is the major factor in the majority of landslides that are not caused by earthquakes. So inside this device, the water pressure is gradually increased within the soil sample, and its behaviour is then monitored on a computer.
So this is the water pressure increasing, simulating the rainfall, and as the rain falls onto the soil and sinks through, the water pressure in the soil goes up. This is the movement of the landslide. Initially there's no movement, and around about here we start to get a little bit of movement. The landslide is starting to slide, starts to accelerate, and then suddenly, round about this point, it suddenly fails and the landslide accelerates downslope to a catastrophic failure.
Another technique they have developed is to use lasers to scan a suspected landslide site. The laser scans back and forwards across a slope to build up an exact image. This can then be mapped into a detailed 3D model, and any subsequent movement is then detected by comparing a new scan to the original model. By interpreting the pattern of movement in a slope at an early stage, they can then extrapolate its likely behaviour in the future.
It's quite exciting because we are now in a position to be able to predict pretty much exactly when a landslide might happen and how fast it might be when it does occur. This is done really in a very simple way. We measure the movement of the landslide, perhaps just by putting in some pegs into the slope and measuring the movement of the pegs. And we can interpret the movement pattern of the landslide to tell us what we think the slope might do in the future. And under certain conditions we can actually predict exactly when the slope might move and whether it will be a catastrophic, a very rapid failure, or a slow movement.
In the case of small-scale landslides, a few hours' warning could save lives, and the Landslide Centre believe that in the case of large-scale slides they could predict them days or even weeks ahead. This life-saving expertise is currently being deployed in a number of countries in the developing world, and is also being used to advise on the construction and siting of roads in areas like Nepal, where 70% of roads are destroyed within 3 years.